Hello everyone and welcome back. My name is Mr. Koval, and in this video we're going to do another kinetics reaction type problem. So let's get into this. Okay, so in this problem we're asked to consider two reaction vessels, one containing substance A, and one containing substance B with equal concentrations at T equals 0. If both substances decompose by first order kinetics, where Ka, the rate constant for substance A, is 4.50 times 10 to the negative 4 per seconds, and the rate constant for substance B is 3.70 times 10 to the negative 3 per seconds. How much time must pass to reach a condition such that the concentration of A is going to be equal 4 times the concentration of B? Okay, so how in the world do you even begin this sort of problem? Well, let's start by writing out the equations for the integrated rate law for a first order reaction for both A and B. Okay, so for A, we have the natural log of concentration of A at time t is going to be equal to negative KT plus the natural log of the initial concentration of A. And for B, it would be the same. So it would be the natural log of the concentration of B at time t equals negative K. Oh, I should specify this is Ka and this is Kb because those are different, times T plus ln of the concentration of B, the initial concentration of B. Okay, now we also know that the initial concentrations are the same, right? So we're told that T equals 0. They have equal concentrations, A and B. So let's write that out. So we have the initial concentration of A is equal to the initial concentration of B. And at a certain time t, which is what we're trying to find, the concentration of A is equal to 4 times the concentration of B. So we have that as well. So let's just write that up here so we know that this is time t. So A, the concentration of A at some time t is going to be equal to 4.00 times the concentration of B at some time, whatever that time is. Oops. Okay, so now that we have that, what we could do is substitute these in for B, right? So here we have, or we could do it for A, right? So at time t, the concentration of A would be equal to 4 times the concentration of B at that time. So we could substitute that in. So instead of ln of AT, we could have ln and substitute in 4.00 times B. So that would be ln of 4.00 times the concentration of B at some time t. So I just took this and substituted in for A sub t. And then we have equals, and that's going to be negative K sub A times t. And because the initial concentration of A is equal to the initial concentration of B, I could substitute this for this, right? So I could substitute in instead of ln of A sub 0, we could have ln of the concentration of B sub 0, the initial concentration of B. So again, all I did was take these two substitutions and put them in here and here. So now I have this equation in terms of B, and I have this equation here in terms of B. And then what I can do is, going back to your solving of system of equations, one thing you learned before, perhaps in high school or way back when, is that you can subtract one equation from the other to eliminate certain things, and that help you simplify the equation. So we have two unknowns here. We have we have a few unknowns, but we can get rid of some of these unknowns by subtracting one equation from the other. So I'm going to take this, I'm going to subtract this equation, the bottom of the equation here, from this equation here. So it's going to be this minus this. So if I write that down here, I'm going to have the natural log of B to the concentration of B at some time t minus the natural log of this. So it's going to be 4.00 times the concentration of B at some time t. Okay, so I subtracted this from this. I got that there. That's going to be equal to negative Kb times T minus the negative Ka times T. So minus negative Ka times T. And then I've got the natural log of B, the concentration of B. So plus the natural log of the initial concentration of B minus the natural log of the initial concentration of B here. So I have minus natural log of the initial concentration of B. So this is my resulting equation where I subtracted this one from this one. Okay, so now I can use the natural laws of logs here. So whenever you multiply two things together, within the argument of the natural log, you can separate those and you can have the natural logs added together. So let me show you what I mean. So I'm going to have the natural log of the concentration of B at time t here minus the natural log of, let me see here. So I'm going to put brackets around that, minus the natural log of 4.00 plus the natural log of concentration of B at time t. So I took this here, and since the 4 is multiplied by the concentration of B at time t, since those are multiplied together and they're within the argument of the natural log, I can separate those by making them add together, right? So whenever you add two natural logs together, whatever these are added, you can put them in the argument as multiplied together, and then you can work backwards the other way too. And so I have the negative here, the minus sign is here. We'll come back to that in a moment. And again, this is going to be equal to this. I can pull out the t here. So I'm going to pull out the t. And here, let's first, I have a negative and a negative. So that's going to be negative Kb times t. And the negative times the negative gives me a positive. So that's going to be KAT. And then I've got, again, plus the natural log of the initial concentration of B minus the natural log of the initial concentration of B. Okay. Now, I can distribute this negative to what's in here. So this is going to be, let's see here, negative B, or it's going to be ln of B minus ln B. So we're going to distribute this negative sign to those two. Okay, so then if I write that, it's going to be ln of B at some time t minus the natural log of 4.00 minus the natural log of B, the concentration of B at time t, equals, now I can take out the t here, so this is going to be t times Ka minus Kb plus the natural log of the concentration, the initial concentration of B minus the natural log of the initial concentration of B. Now you're probably wondering, why haven't I canceled stuff out? Well, I'm going to do that now. So here I have the natural log of the concentration at time t, and I have negative natural log of the concentration of B at time t. So those are going to cancel out. And then over here, of course, the natural log of the initial concentration of B minus the natural log of the initial concentration of B, that's going to cancel out. Excellent. So we got rid of those variables that we didn't know, and now we have one variable left, which is what we want. So now we have a much more simplified equation. We're going to have the negative natural log of 4.00 is going to be equal to t times, now we can plug these in, so Ka is 4.50, so it's going to be 4.50 times 10 to the negative 4, and that's per seconds, minus Kb, which is 3.70, so 3.70 times 10 to the negative 3 per seconds. Now, when I subtract these two from each other, I get negative 0.00325. So the negative 4.00, negative natural log of 4.00 is equal to t times negative 0.00325 per seconds. Let me double check that. Yep. And now all I need to do is divide both sides by negative 0.00325 per seconds. Divide this by negative 0.00325 per seconds. The negatives cancel out, so that's positive. And when I divide this, I get t time is equal to 427 seconds of time. So at 427 seconds, when both reactions are started, then at this time, the concentration of A at this time will be equal to 4 times the concentration of B at that time. So that, ladies and gentlemen, is how you solve this problem. If there's an easier way, if you know another way that you can solve this problem, put it down below. Let me know about it. I would love to hear what that other technique or strategy is. If this video helped you out, if you enjoyed this video, if this helped you in any way, then please by all means like the video, share the video, hit that like button. Also, do me a solid, subscribe to my channel, help me out. Subscribe and then hit that notification bell up there. When you do that, click all so you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.